This is June 09, question 5. Terms often used in describing an electrical power source such as a battery are terminal PD and EMF. Write a short explanation. Now they're not asking you to say what do they stand for, and so rather than say EMF is electromotive force, you need to just give a wee brief explanation and when it is appropriate to use them. So EMF is the potential difference across the output terminals of a source or battery. Since they've said power source, so should you. When no external load is there or no current is being drawn. From the source. And then terminal PD is the PD across the terminals when a current is being drawn, and it should be lower than the EMF. So PD drawn from the source. Sorry, PD across, I shouldn't say drawn, across the source when a current is being drawn from it. I'm going to put, in other words, when there's a load across it. So there's quality of written communication in this question, which just means can you write that in a nice sentence rather than just, stating something. Part B, what is meant by the internal resistance of an electrical power source? And so that is just the opposition to current flow. So you wouldn't use the word resistance again if you're explaining it. Opposition to current flow through the electrical power source. Okay, part 2. Obtain the relationship between the EMF, the terminal PD, and the internal resistance R when a power source is used to provide a current I to an external resistor of resistance R. So I'm just going to draw a wee circuit. I'm going to put the internal resistance R, small r, beside the EMF, and I'm going to put a resistor here, and I'm going to write V, and I'm going to put a current I as well. And so you should be able to see there that E is equal to I times R plus I times big R. So E is equal to I times small r plus I times big R. Now you're asked to obtain the relationship between E, big V, small r and I, and so we have to get rid of this and write the V instead. So that's IR plus V. And we're asked to write down E minus V, so just rearranging that, E minus V is equal to I times small r. And that's your answer. State the necessary condition for electrical power source to supply maximum power to an external load resistance, and that's when the value of the external resistance R is equal to the internal resistance of the battery.